All right, everyone. I want to just give a quick intro to VSEPR theory, and then I've got actually some other videos linked this time around for a full walkthrough, and then we'll look at it in a lot more detail with the lab. So VSEPR theory stands for valence shell electron pair repulsion theory. And what that tells us is that if you have electrons, right, there's a pair of electrons. Let's say there's another pair of electrons over here. They're hanging out in the same general proximity, and this theory says they're going to repel each other. We know that already, right? But what VSEPR theory tells us is how that then determines the shape of molecules, because if we have a molecule like methane, right, let's remember that each of those bonds is in fact an electron pair, right? So now we see, oh, wait a minute, all of those electron pairs are repelling each other. What? Right? And this is where sorry, this is what VSEPR theory allows us to do, okay? So the cheat sheet you have, and I'm just gonna zoom real quick, right? Here, this is your VSEPR geometries. Note, you guys at the SL level do not need to worry about these bottom two. I didn't even include it in the cheat sheet that I gave you on the lab, okay? We only have to worry about up to 4 electron domains on this sheet, and I believe it uses the word steric number, same thing. Sorry, same thing, but we need to call it electron domains, okay? Then you have your geometry, right? Geometry talks about how the electrons are arranged, or are, let's say, arranged in space. Why not? Right? And then you have your shapes, right? That's your geometry. Your shapes are, ooh, it's not listed here, but on your sheet, they are listed right here. Shapes, 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 right? The red is your shape. And it all depends on how many of those electron domains, how many of those regions where there are electrons are actually bonds. That's the difference between the geometry and the shape. Okay, so just a quick summary on that, right? Geometry refers to the electron domains, period, okay? The shape is then dictated by how many are bonding versus not. Right? So if we have, I'll go purple, right? If we have this first guy here, it's going to have 2 electron domains, and it's going to have no lone pairs. This is all around the central atom. Everything is focusing on the central atom. And so it's going to have 180 degrees. The geometry, right, is going to be linear. And the shape is also going to be linear, okay? Next one down with the 3 domains, we have our 120-degree separation, and we're going to have a geometry for all of them. Geometry's in green, sorry. That is going to be trigonal planar. Okay. And you just have to memorize these names. That's it. Then for shape, right? Again, I'll do shape in red. You're going to have the first one with no lone pairs that is also trigonal planar. And this is all already on your sheet, so I'm not worried about writing this neat right here. You have this document with the names on it. However, if you turn one of those electron domains into a lone pair, right? So that's saying we started with the three groups, right? It's different than our first model, 3 groups. We're going to take away one of them and replace it with a lone pair, right? Remember I was saying use the big balloons for your lone pairs. And notice it smushes those a little closer together because these guys are more repulsive. The lone pairs push harder is the way you want to think about it. Okay, so you're going to end up with an angle that is now different and a shape that is now different. And so for the single lone pair and 3 electron domains, that's where you get a bent or angular shape. Okay, and we notice, I'm just going to zoom because that's just getting silly. We notice that here, that bond angle is less than 120 degrees, whereas here it is 120 degrees, right? Nothing going crazy. Those are going to separate by 120 degrees. Okay, that's the farthest away from each other they can get in a flat plane, 100-degree separation, because then they have 180 in the up and down planes. Okay? And then this just keeps on going. So this is VSEPR theory. Again, I've uploaded those other videos, and I think they'll just walk you through it a lot nicer. For some of you, maybe this is enough to orient you and then the book and you're good. But do watch the first little bit of that other video because it's just funny to me. And that gets you to VSEPR theory. Okay, so that's what you're looking for. You are wanting, or I am wanting you to be working through, figuring these out, wedges and dashes for 3 dimensions. Just start practicing. Okay, real quick, I just wanted to pop over here and show you a little bit with the modeling. And so to see what happens here, right? So there we have our 4 lone pairs, right? And those are all bonding, or not 4 lone pairs, I'm sorry, 4 electron domains. They're all bonding. If we turn one of them into a lone pair, look at what just happened there, right? It was there big and wide. Now it's there and it's been crunched in a little bit. I think this is showing that. I don't know if it's showing it as well as I want it to, but let's come back. Seasickness. Okay, there we go, whatever. Take away another and we get that bent shape because the other electrons, they're not attached to anything. They don't have anything to do with the shape, right? They're not part of the tangible part of the molecule. They're just extra electrons that are hanging out there. Okay? Again, you do not need to look at things bigger than 4 pairs of electrons. And also, if you ever just have 2 things, it's linear. 2 points, connect them, you make a line. Easy, end of story. So there's a bunch of 2 atom compounds on your list for your lab. They're all linear. Just roll with that. Okay. All right, that's it for now. And I'll see you soon.